Okay, so I will be solving another question on ICR. Okay, I solved question number 5 from the same page, from the same textbook. So I will now be solving question number 7. Okay, so the first two steps, like before, are write down the given data and write down what we have to find. So I have already done those two steps. So we will move on to step number 3. As you might remember from the previous question, step number 3 is to draw the space diagram. Step number 3 is to draw the space diagram. What do you mean by space diagram? This diagram, which is given in the question itself. This is your space diagram. You have to draw it on your A3 sheet. You have to draw this diagram on your A3 drawing sheet. Okay. So we will start doing that. In the last question that I solved, I drew the space diagram with pencil, and even I saw that it wasn't exactly visible. So I will be drawing the space diagram with pen this time, but you shouldn't draw it with pen in the exam. Draw it with pencil. Okay. So before drawing, we have to check what is the size that we have to draw. As you remember, we have to draw it in this small space itself. Okay, 10 centimeter by say 12-13 centimeter. Okay, within that we have to fit this space diagram. So what is the length, what is the height of this space diagram? See, this is 45 mm, this is 55 mm. Total height is 100 mm. Total height is 100 mm. What is the width? 25 mm plus 75. That is 100 mm plus a little bit. I don't know exactly how much, but it might be about 120-130 mm. So it is 100 mm, that is 10 centimeter by 13 centimeter. So that is perfect. This much can be fit into our space diagram in this place. Okay. Why do we draw it so small? Because the ICRs are farther apart. They can be anywhere on this whole page. So we draw the space diagram in between so that all the ICRs will come on the page itself. Okay, so in this case we don't need a scale. The scale is the true scale, that is 1 centimeter is equal to 1 centimeter. Okay, but still we have to write it. Okay, so top right we write scale on both axes. You can write it over here or afterwards also. 1 centimeter is equal to 1 centimeter. 1 centimeter means 10 mm. Because their dimensions are mm, so I will write 10 mm. You can write here also on both axes. It is also acceptable. Okay, so we will start drawing the space diagram. This time I am drawing it with pen, just so that you understand it better. Okay, so I will start from the top right this time, because that is the first ground that has been given. Okay, this time I am drawing it with pen just so that it is visible in the video. In the exam, draw it with a pencil, not a pen. Okay. As soon as you draw this, you have to draw a horizontal line. As soon as you draw the ground, draw a horizontal line. To that horizontal line, draw a vertical line at 90 degrees. Okay. Okay. So here is the 90 degree. Now in this case, I know that the first link is at 30 degree. So I am marking that 30 degree right now itself. Okay. Okay. I have just marked the 30 degree also. Okay. So draw this vertical should be very light. These two lines should be light. So I am still drawing them with the pencil itself. But this link I will draw with a pen. Just a minute. First I will mark this 30 degree. This is a 30 degree line. You might not be able to see it. Don't worry. I will draw it. And the first link, they have given the length as 25 mm. Okay. So first I will mark that 25 mm over here. Okay. I have marked the 25 mm, and now I will draw it with a pen just so that you are able to see. Okay, in the exam, draw it with a pencil. This becomes my first link. This is 30 degree. This is 25 mm. Okay. After this, I will draw the other grounds as well. Now see, you have to use your brains when drawing this space diagram. So they have given me this 25 mm and this 45 mm, that there is another ground, 25 mm and 45 mm. So I'll just mark it out. Okay. From here it is 45 mm one and another is at 10. Okay, you can see the question if you like. These will be the markings that I will be using. Okay, so these will be the markings that I will be using. Draw the grounds, and from here 25 mm, and from here 75 plus 25 100 mm. Okay, so take this parallel to this, move downwards to this point, make a horizontal line temporarily. I will mark it with a pen, just a minute. So let me draw these horizontal lines. Okay, so from here it is at 25 mm. So now with a pen at 25 mm is my another ground. Okay, this is another ground, and from here 100 mm, 10 centimeter is my third ground. Okay, all this is given in the question itself. Space diagram is same as in the question. Okay, okay, so this part is done. Now what they have said, this link, the link which is over here, that is also 100 mm, and this link is also 100 mm. So I will take my rounder, take 100 mm, that is 10 centimeter on it, take 10 centimeter on it. Okay, from here make an arc, from here make an arc, that is where it is intersecting. Okay, here draw this, here draw this. Okay, that is done, and they have said that from here 25 mm there is another link. Okay, so from here 25 mm, okay, this point, this link is also 50 mm, this link is also 50 mm. They have given it in the question. Okay, 50 mm, 50 mm. So I will take this again. 50 mm means 5 centimeter. Okay, 50 mm, 50 mm, mark it. Okay, done. This part is now done. Now if you see in the question, they have given it this link name A, this link B, D, C, E. Okay, I am not comfortable with naming them with alphabets, so I will just number them as we always do. Okay, so our numbering always starts from 1, and our ground link is always given number 1. So this will be my link number 1. This is ground. This is also ground. This will be link number 1. Link number 1. This will be my link number 2. This whole is a single link. That will be link number 3. I will name this as link number 4. This will be link number 5. This will be link number 6. Okay. So I have my 6 links. Okay. Now all these points, the points where two links are connecting to each other, they are important. I should name them. But in the last question, I named them A, capital B, capital C. But in this case, I cannot name them with capital alphabets, because in the question, they have named these links with capital alphabets. So I will use small a. For this point, I will use small a, small b, small c, small d, let us say small e, small f, and small g. Okay. After this is done, this is your space diagram. This part is done. Now we move on ahead. Okay. So after drawing the space diagram, you take your answer sheet. Okay. Space diagram done. What is step number 4? Step number 4 is listing all the ICRs. Okay. Now how many ICRs do you have? Listing all the ICRs. Now how many links do you have? See, we have 6 links. Overall we have 6 links. So if you have 6 links, you write only from 1 to 5. That is, if you have n links, you write till n minus 1 link. So it will go link 1, link 2, link 3, link 4 and link 5. Okay. Then whenever you are numbering ICRs, how should it go? 1 number bigger than 1. 1 2. Then 1 3. 1 4. 1 5 till what? Link number 6. Okay. We are done with that. Now link number 2. Bigger number than 2. 3. 2 4. 2 5. 2 6. Link number 3. Bigger number than 3. 4. 5. 6. Here it will be 4 5. 4 6. It will be 5 6. That is why we don't write 6. There is no number bigger than 6. Because we have only 6 links. Okay. So we have total 15 ICRs. Okay. Now we have these 15 ICRs. We also have to draw a circle. Okay. You can take any diameter, any radius for this circle. Just make sure that the circle is big enough. Okay. That is the only thing. This marking should also be done with pencil. But for the sake of the video, I am doing this with pen, so that it is visible to all. Okay. Okay. Now the part of your answer sheet is done for now. We'll again go back to your A3 sheet. Okay. Now what do we have to do? We have to mark all the ICRs, revolute and sliding ICRs. Okay. See, here is a revolute pair, revolute joint, revolute joint, revolute, 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 revolute. There is no sliding joint in this question. Okay. At this joint, which two links are coming together? Link 1, which is ground, and link 2. So this ICR will be I1, 2. Here what are coming together? Link 2 and link 3. So this is I2, 3. Here link 3 and link 5. So this is I3, 5. Here link 3 and link 4. I3, 4. Here link 1, which is ground, and link 4. So I1, 4. Here I3, 5 is done. Here link 5 and link 6. I5, 6. Okay, and this link 6 with ground, link 1, I1, 6. Okay, so I have marked all the revolute joints, okay, with the corresponding ICR. Okay, now I have to cut these ICRs in this. Okay, so what all I have marked? 1 2 2 3. So I will cut 1 2 2 3. Then 3 5 3 4. 3 5 3 4. 1 4 5 6. 1 4 5 6 and 1 6 also. 1 6. Okay, 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. Right. 7 have been cut. As soon as I cut them, the next thing that I have to do, whichever pair I have cut, I have to mark it on the circle. So I take, in this case I will use a pen, in your case use a pencil. I have cut 1 2, so I will mark 1 2. I have cut 2 3, I will mark 2 3. I have cut 3 4, I will mark 3 4. I have cut 5 6, I will mark 5 6. I have cut 3 5, I will mark 3 5. I have cut 1 4 and 1 6. So I will mark 1 4 and I will mark 1 6. Okay. So I have marked all the ones. 1 2 3 4 5 6 7. Right. 7. Okay. So done. We are done till now. Now many of you will try to find all the ICRs. Remember, it is not necessary to find all the ICRs. You have to find only those ICRs which are necessary for the question. What is the question? To find angular velocity of E. E. If you see the question, this link is E, the one that we have numbered 6. So what do we have to find? We have to find angular velocity of link 6. That is our question. Okay. So for that we can make a list that what all we have to find. Okay. How does it go? First of all, what is the known quantity? What is the known quantity? Which quantity do we have to find? To find this quantity, which are the links that we are interested in and which are the ICRs that we are interested in. Okay, this is what we have to do. Okay, so which is the first known quantity? We know only one quantity. See, angular velocity of A. If you look at the question, this link is named as A by them. We have named it 2 because I don't like alphabets, that is why I have named it 2. So what do we know? We know angular velocity of 2 is 10 radians per second. So that is the first thing that is known to me, angular velocity of 2. Now using angular velocity of this link, I can find out the velocity of B. I explained this in the previous question. Okay, V is equal to R omega. This is fixed. This is performing pure rotation. V is equal to R omega. So we have to find velocity of B. To find velocity of B, which is the link we are interested in, only link number 2. Only link number 2. So which ICR are we going to use? First write I1. Whatever is written here, write over here. So I12. Okay. So this will be our first step. In next step, what is the known value? Velocity of B. See, this is B. B is combination of which two links? Means B lies on which two links? It lies on link 2 and it lies on link 3. So we can, knowing the angular velocity of link 2 and velocity of B, we can find out the angular velocity of link 3. Okay, what I am saying, by knowing the angular velocity of 2 and by knowing the velocity of B, we can find the angular velocity of 3. Why? Because B is connected to both. For further explanation, you can go back to the previous video where I have explained all this. Okay, B lies on which two links? 2 and 3. So here 2 and 3. Always remember, to find the velocity we need only one link. To find angular velocity we need 2 links. Okay, so this is 2 and 3. So here we write I1 2 and I1 3. Okay, as soon as we find out the angular velocity of 3, now see, this is a interesting case. In this link there are 3 points, B, C and D. B, C and D. We know velocity of B, we know angular velocity of 3. We can find out the velocity of C also, we can find out the velocity of D also. But see, in the question what is asked, they have asked us the angular velocity of E. So finding the velocity of D, we will be able to find the angular velocity of 4. We are not interested in this angular velocity. We don't need this angular velocity. We need this angular velocity. For this angular velocity, we need this velocity. For this velocity, we need this angular velocity. For this angular velocity, we need velocity of C and not of D. So we are going to find velocity of C, not velocity of D. Okay. So using angular velocity of this link, we are going to find velocity of C. Okay. We are going to find velocity of C. Whenever we have to find velocity, we need only one link. Which one is that link? This link number 3. Okay. So this will be I13. Okay. Now knowing velocity of C, C lies on which two links? Link 3 and link 5. So we can find angular velocity of 5 because we already know angular velocity of 3. We can find angular velocity of 5. For C lies on which two links? 3 and 5. So we are interested in 3 and 5 link. So we are interested in I13 and I15. Okay. So knowing angular velocity of 5, we can find the velocity of F, linear velocity of F. Angular velocity of 5 is known. We can find linear velocity of F. Vf. Which is the link we are interested in? Link 5. So I15. Knowing velocity of f, what can we find? F lies on which two links? 5 and 6. We know angular velocity of 5. We can find out the angular velocity of 6. Okay. So we are interested in links 5 and 6 because f is on links 5 and 6. So I15 and I16. This is what we have to find. So we have to do these 6 calculations. But to do these 6 calculations, we should know all these ICRs. We should know all these ICRs. So which ICRs are required? I12, I13, I15 and I16. Out of this, see, 12 is already marked, 13, okay, we have to find 13, 15, we have to find 15, 16, 16 is also already marked. So you have to find only I13 and 15. So first mark this with dotted line, with pencil, with pencil. This is just for viewing purpose. Okay, 13. I need I13. To find I13, I need such two pairs that jump from 1 to 3 in 2 steps. That is, see, to go from 1 to 3, how can I go? So I can go from I 1 to 3, how? 1, 2 and 2, 3. 2 steps. 1, 2, 2, 3. 2 steps. Similarly, if I have to go from 1 to 3, 1, 4, 4, 3. 2 steps. So I reach to, I get these 2 steps. So I can find I13. How? Take these two ICRs, draw a line through them and extend it. Take these two ICRs, draw a line through them, extend it. Where these two lines intersect each other, that will be your I13. Similarly for I15. Okay. First draw a dotted line. For I15, in how many ways we can go it in 2 steps? See, we can go 1, 6, 6, 5, 1, 6, 6, 5, 1, 6, 6, 5. But there is no other way. See, 1, 4 doesn't give me, 1, 2 doesn't reach there. But see, 1, 3, 3, 5 reaches there. 1, 3, 3, 5 in 2 steps. 1, 3, 3, 5. Okay. So to go to 5 or to find I5, I will first have to find I3. Only after finding I3 will I be able to find I5. So first I have to find I13, then I can find I15. Okay. To find I13, I have to first take these two and these two. Okay. So I have to go back to my A3 sheet. Okay. So I12 and 23. So this is 1, 2 and 2, 3. Extend this line. Okay. 1, 2 and 2, 3. Extend this line. Okay. And which are the other twos? 1, 4 and 4, 3. Means 1, 4 and 3, 4. See, 3, 4 is here, 1, 4 is here. 1, 4 and 3, 4. So this will be the second line. Okay. Just so it is visible to you, I will use red pen. Okay. So extend this line 1, 2, 2, 3. Extended this and this line 1, 4, 3, 4. So it will intersect over here at this point. This becomes your I13. Okay, this becomes your I13. Okay, now I have found out I13. Very good. Now I have to find I15. For 15, what is 1665? Means 1656. Here is your 16, here is your 56. So I will have to extend this line. Okay, I will first do it with pencil, then with the red pen. 1656. And which is the other one that is required? 1656 and 1335. Here is 1335. Okay, 1335. Okay, it is intersecting over here. Okay, I will do it with red pen. 1335 and 1656. Okay, it is intersecting over here. This becomes my I15. I15. Okay, so I have found out I15, I13. Okay, so all that was required has been drawn. Okay, so I can cut it over here also. Okay, 1315 is done. Okay. So now I have to do all these 6 calculations. Only then I will be able to find out the angular velocity of 6 to do all these 6 calculations. Okay. Okay. First of all, I have to find velocity of B knowing angular velocity of 2. Okay. How do I do this? I will do over here. Velocity of B. Whenever you have to find velocity of B, using which ICR? I12. What is the formula? Length of B. See here B, here B. Which ICR? I12. I12. This is length into omega 21. Okay, in the last sum, I used omega 12 notation. Okay, that is wrong. You have to use 21. Okay, it doesn't matter what you write, 1, 2, 2, 1. It is okay for this question, but this is the correct way to write. Angular velocity of 2 with respect to 1. Okay, let it be. Okay, length of B I12 into angular velocity of 21. Okay, do we know length of B I12? Yes, we can find it from here. Here is B, here is I12. This length we already know. This is the length of link A, that is 25 mm, or we can measure it using a scale also. No problem. If you measure it, it will be 25 mm. Okay, so 25 mm is 0.025. What is the angular velocity of 2? Angular velocity of 2 we already know, 10 radians per second. So this is 0.25 meter per second. We know velocity of B 0.25 meter per second. Okay, so we found out velocity of B. Now using velocity of B, we have to find angular velocity of 3. Okay, so what did I teach you in the last class? For angular velocity, what we require? 2 and 3. Links 2 and 3. How should that formula be? Link B I12 into omega 21 is equal to length of B into I13 into omega 31. Okay, 2 and 3. See, 2 and 3. B from here. I1 is going to remain constant. Here 2, so omega 21. Here 3, so omega 31. Now we know this value, length B I12 into omega 21. See, same. It is 0.25. 0.25 is equal to what? Length of B2 I13 into omega 31. Now how I should measure this length? B2 I13. Here is B. Where is I13? Here is I13. Okay, I will measure this length. It is 10.1 centimeter. Okay, the length is 10.1 centimeter. 10.1 centimeter into 10, 101 mm. Okay, 101 mm into omega 31. So my omega, okay, let us consider it as 100 only. Okay, so omega 31 becomes 0.25 divided by 0.1. Okay, so this will be 2.5. Okay, this will be 2.5 radians per second. So I found out omega 3. From omega 3 I can find out velocity of C. How to find out? Velocity of C is equal to length of C into I13 into omega 31. What is length C I13? I don't know. I will have to measure C I13. It is nearly 61 mm. Let us say 60 mm. Okay, just to round off. Okay, 0.60 mm. Okay, 60 mm into omega 31 is 2.5. Okay, calculator. .06 into 2.5. We get 0.15 meter per second. That's right. Okay, 0.15 meter per second. Now, knowing velocity of C, we can find angular velocity of 5. Using what? I13 and I15. So, how goes the formula? Velocity of C is length of C to I13 into omega 31 is equal to length of C I15 into omega 51 is equal to, this is same, we know 0.15. What is length of C2I15? Okay, you will have to see. Where is C? Here is C. Where is I15? Here is I15. C2I15. It is nearly 50 mm. Okay, 49 mm. Okay, so 50 mm. Okay, 0.05 into omega 51 implies omega 51 is equal to 0.15 divided by 0.05 is equal to 3 radians per second. Okay, so I know omega 51, that is omega 5. Now from omega 5 I have to find velocity of f. Okay, velocity of f, same formula, f into I, this time what is 5, 15 into omega 51 is equal to, what is the length between f and I15? I will have to measure f and I15. Okay, this one 30 mm, nearly 30 mm, it is 31 mm. Okay. Okay, do not round off like this in the exam. I am just doing it because it will make my work faster. Okay, so 3 radians per second. Okay, so it is 0.09 meters per second. That is velocity of f. Now using velocity of f, I have to find angular velocity of 6. Okay, velocity of f is equal to length of f. Which are the two ICRs? I5 and I6. I15 omega 51 is equal to length of f into I16 into omega 61. Okay. F into I15 0.09 is equal to length of f2 I16. f2 I16. This is f. Where is I16? Here is I16. Okay, that is 50 mm. I know it is given in the question itself. Length of link key. Okay, so this is what? 0.05 omega 61. So omega 61 is equal to what? 0.09 upon 0.05. How much will it be? 1.8 radians per second. Okay. So the actual answer is 1.94 because we rounded off so many times. So it has come close by. Okay. In exam it won't matter. Even this much difference might be acceptable. Okay. As long as you have done the steps correctly. Okay. So this is omega 6. What we were interested in. We found it out using this. So 1.8 radians per second. Okay. So this is the second sum that I have solved. I will try to solve one more university question to complete this ICR off, after which I will start the velocity diagram sums. Okay, and after that acceleration diagram. Okay, thank you.